All right, so today we're going to be finding that slope from a table. We already talked about previously, we know how to find slope from a graph, right? I can represent linear relationships in a graph. I can also represent them in tables. So today's focus is going to be on the table. All right, I'm going to cover this up for a minute. We learned earlier this week that I could find the change in a y value, the change in x values when we're using a graph by the strategy of rise over run. Remember, rise represented my vertical change, the change in the y. Run was the horizontal change, change in the x. Well, if I have this table here, could I take these x and y values and make an ordered pair, then graph all the ordered pairs, find two pretty points, make the line, count rise over run? Could I do that? Yes. Is that a lot of work? Yes. There's another way that I can just use the information in the table to calculate, to mathematically calculate slope. And that is where this comes in. This is kind of like mathematical shorthand. This symbol right here is called a delta symbol. And what it literally means, delta is the mathematical symbol for the word change. Delta means change. It is the delta symbol. So I would literally read this as the change in y over the change in x. It's the same thing that says here, except it's kind of like shorthand. I'm writing it with symbol, a symbolic representation, instead of having to write out the word change every time. Okay? So let's look at this table. I know I'm trying to find the change in y over the change in x. It's kind of like our formula. Kind of like the formula that we write down first. Change in y over change in x. So we're actually going to go to the table. We're going to look, how are my y values changing? How are my x values changing? So if I look at this first set of ordered pairs, I have 0, 1, and 1, 4. So in this first set of ordered pairs, from 1 to 4, are my y values going up or down? Up. Is that adding or subtracting? So I'm adding how many? 1 plus what gives me 4? 1 plus 3. So that means my y value is changing by a positive 3. My y value is changing by 3. Well, let's go look at the corresponding x's. How are my x values changing? I'm adding by 1. So that's a positive 1. So that means my y values are changing by 1. And we know that 3 over 1 can simplify to what? To 3. Well, let's go ahead and look at our next set of x values and y values. If I use the ordered pairs 1 and 4 and 2 and 7, what if I picked those two to use instead? How is 4 changing to 7? Are we adding or subtracting? Plus 3. So then my change in y is 3. What about if I use the same corresponding x values? How is it changing from 1 to 2? Plus 1. So far, is that slope the same? Does it simplify to 3? Yep, so they're the same. But now look what happens in the next set of values. What if I want to use the ordered pairs 2, 7 and 4, 13? How is my y value changing from 7 to 13? We're adding 6. So my change in y value here is 6. Well, what's my change in x values for those 2 points? Plus 2. So 6 over 2. Can I simplify that? What is that going to simplify to? 3 over 1, which simplifies to 3. So even though my table was a little bit different, do you see how we had the same slope? All this means, what did they do on the table? They skipped the x value of 3, didn't they? That just means they didn't put 0, 1, 2, 3. They just skipped it. They just didn't put that point in my table. Yeah, they kind of took a shortcut. All right, and then so then if we look at the last set of data, 13 to 16, how does that change? Plus 3, so that's 3 over. From 4 to 5, plus 1. 3 over 1 is 3. So every time I got the same slope, the same change in y over the same change in x. Well, we know slope is just the rate of change. So what was my slope for this table every time? What was the slope? 3 over 1, which simplifies to 3. Because every time I got the same answer. And we should get the same answer. Because a line, in order for it to be linear, it has to have that same slope throughout the entire line, right? I can't have a broken line. That's not linear. Okay? All right, what is the y-intercept? We can actually find that from the table. Who can refresh my memory? What is a y-intercept? What does that mean? Yes. Right, it crosses the y-axis. And if it crosses the y-axis, that means its ordered pair is always 0 for my x value, and then some number for the y. Because if I'm plotting the point, I can't go left or right on the x-axis, can I? I have to stay at 0 so that way I stay on that y-axis. So knowing that my ordered pair has to be 0 y value, what would be my y-intercept in this table? 0 and what? So if my ordered pair, 0, 1, what would be my y-intercept? 1. Because the ordered pair tells me that that point is going to be on the y-axis at 1. 0, 1. Please make a mental note. This 0, 1 is not the y-intercept just because it's listed first in the table. It could have been listed anywhere. I need that x value to be a 0. It was just coincidence that it was listed first in the table. Okay? So is it always just the first thing listed? No. How do we know it's the y-intercept? 0 is on the x. Because if I have to plot that point, I got to stay at 0 and then either just move up or down for my y value. Okay, let's open up the notes. Yep, now we're on let's practice. So how do I find slope from a table? Am I going to count rise over run? Nope. What am I going to do instead? Change in y over change in x. Delta y over delta x. And we just say that as change in y over change in x. All right, so let's look at my first set of y values from the first 2 points. If I'm starting at -3 and I'm going to 2, am I going up or down my number line? Up, so that's an addition word, right? So how much am I adding to -3 to end up at 2? I'm adding 5. So my y is changing by a value of 5. And then how is the corresponding x's changing? Plus 2. 5 over 2. Whoops, I wrote a 5 over 5. over 2. All right, let's verify. That should tell me right there that's the slope. Because I just picked up a change in y and a change in x. And we should know that's the slope because every other, no matter what 2 points I pick, I should get the same slope, right? If they're on the same line, my slope has to be the same. Well, let's check. How is from 2 to 7? What's happening? Plus 5. 2 to 4. There's my plus 2. So does that still give me the ratio of 5 over 2? Yep, we're good. What about 7 to 12? Plus 5. 4 to 6? Plus 2. 5 over 2, same thing. Even if I would have got different numbers, is that still okay? Yes, as long as it simplifies to the same number. So what's my slope here? 5 over 2. Can I simplify that anymore? No. What is my y-intercept? It is the ordered pair of 0, -3. So my y-intercept is what y value? -3. Very good. Any questions so far? Poll check. Do you like finding tables better or graphs better?
Table.
It's been about 50-50 all day.
Table.
All right. Let's look at the next example.
Oh, wait, this chocolate table, I forgot.
Tables.
Oh, yeah, I love tables.
All right. What's different about this table? It's sideways. It's horizontal. But can I still look at y values and x values just the same? Yes. So no matter what, I'm still looking for the change in y over the change in x. So how is my y values changing from 1 to 3? +2. So my y value is a +2. How is it changing from 0 to 1? +1. 2 over 1. Could one of those values been going down so it would be a subtraction number instead of an addition? Absolutely. That would just mean that I would have a negative slope. All right. So if I only even used one of these ordered pairs, can I already tell what the slope is of this whole table? What is it? Change in y over change in x. So 2 over 1, which does simplify to 2. Could I prove it if I needed to by checking all of the ordered pairs? I could. Do I have to?
No.
No. All right, what's the y-intercept here?
It's 1.
It's 1 because that ordered pair would be what? 0, 1. So then my y-intercept is just 1. Online people, how are we doing with this? Give me thumbs up, thumbs down. I like thumbs up. I like some sideways. That's good too, because we're still practicing. It's day 1 with tables. Yes, did you have a question?
Yes.
Okay, what's your question?
I know graphs and stuff, but how do you know that it all goes to 2 out of 1 by just looking at it?
Okay. Do you understand how we got the numbers here on my table?
Yes.
Okay, so this literally says the change in y. So this part right here is telling me how is the y values changing. I'm adding 2. So I'm just filling in, instead of change of y, I'm going to put how much did the y values actually change. And over here, I'm figuring out the x values is adding 1. It's changing by 1 every time. So I fill that in the x's. So I'm literally just filling in that fraction, that ratio. Okay? Yes? Do I need to explain it another way?
No.
Okay. All right, let's go look at the next one. Can you find the slope? Can you find the change in y and the change in x? I want to know, how is my y values changing? How are my x values changing? I can pick any 2 points right next to each other on the table. It's in a different one, maybe. All right, I'm going to choose these first 2. How is 7 changing to be a 10? +3. So my y values are changing by a +3 each time. So my y values are changing by 3. How are my x values changing? +1. We're counting by 1s here. So it's changing by 1. So that also simplifies to, so what is my slope here? 3 over 1, which simplifies to 3. Anybody feel like I need to check some other points? Y'all feel confident that it would work out? I do too. Okay. You want me to check a different
No,
point?
this is one thing. I just want to know. It's about the y-axis.
Okay.
So is this still going to be the first y, or like?
I could have picked any points. I could have even went down here. What is the change from 16 to 19? It's still plus 3 and a plus 1. No matter what 2 points you pick, you will have the same rate of change. You will have the same slope.
Okay.
Okay?
What about the y-axis?
You mean the y-intercept?
Oh,
Okay, that's what we're getting to now.
I could think
So, how can we find a y-intercept? What does it mean to be a y-intercept? A 0 in the x value. Good. Well, I don't have a 0 here. What do you think? To go what? Go backwards? Okay. I like your way of thinking. I know that each time I go down the table, my y values are adding 3. Down the table, my y values are adding 1. But what if I want to go backwards on the table? Because this is a 3, this is counting by ones, right? So if I went backwards on the table, if I wanted to add more, I would have 2, 1, and 0, right? Agree or disagree? Because if I'm adding 1 to go down the table, to go back, I just subtract 1 each time, right? But if I'm adding 3 to get bigger, if I need to go smaller on the table, what am I going to do? Subtract 3. So what is 7 minus 3? 4. Is 2, 4 the y-intercept? Nope. I got to keep going. So what is 4 minus 3? Is 1, 1 a y-intercept? Nope. I got to keep going. Minus 3. Negative 2. Could 0, negative 2 now match up to be a y-intercept? Yes. 0, 2, or excuse me, negative 2 is the ordered pair. So my y-intercept is negative 2. So sometimes you may have to use the chart and work backwards back to 0 to find your y-intercept. Now, I would not make you work backwards from like 10 or like 7 and have to go all the way back 6, 5, 4, 3. I'm not going to make you go backwards that many times. Okay? But 3, that's a pretty fair amount. We could work backwards 3.
Miss Marlin?
Yes.
So for you to get the y-intercept, it has to have a 0 something?
Yes. Because remember, if I'm graphing that point, if I start at the origin, if I want to go down to negative 2, my x value has to be 0. I can't move left or right for my x value. I can only have a y value to go up or down. Okay? Does that make sense?
Yes, ma'am.
Okay, so it'll always be 0 and then the y value. All right, let's look at our last example. This one's a little bit different. They gave us ordered pairs. What is the slope of a line that will go through the points? Negative 7 and 5, and negative 4 and 7. What are the 2 ways we know how to find slope that we've talked about? I can find slope by using rise over run, which is what? Using a graph. I just learned today that I can also find slope using a table. Well, if these are ordered pairs, could I make a graph, plot the points, draw the line, find my rise over run? Would that work? Yes, it would. Could I also take these ordered pairs and put them in a table? Do I have x and y values in ordered pairs? Which one do you think you might want to do? Most people want to do a table because it's easier than drawing a graph. So if you remember, every ordered pair has an x and y value. Well, what's needed for tables? X and Y values. So let's make an XY table. So let's look at my first ordered pair. When X was -7, what was the Y value? 5. When X was -4, so I'm going to put -4 on the X, what was my corresponding Y value? 7. So how do we feel about taking those ordered pairs, putting them on a table? Thumbs up, thumbs down, thumbs sideways. Good, good. Okay. X, Y values, X, Y table. Well, now I just have a standard old table. Can I use that table to find my change in Y over my change in X? All right, let's look at it. From 5 to 7, are we getting bigger or smaller? From 5 to 7. Bigger, so how much are we having to add? +2, so my change in Y is 2. What about on the negatives? From -7 to -4. Are we getting bigger or smaller? We're getting bigger, right? -7 is smaller than -4. So we're getting bigger. So we're adding how much? +3. So what is the slope of those, a line that would point through those two? 2 over 3 is equal to the slope. You could write the word slope. You could just box in your change of X over change of Y. Remember, the variable M represents slope. Questions? All right, I want you to take a moment and glue this into your spiral. If you completed this online, make sure you have it saved somewhere for good reference.